Hello and welcome back to CST 3130. So in this lecture we're going to cover serverless computing. Right, so I'm going to start with a brief introduction to what it's all about. Then what we're going to be focusing on is the kind of AWS Lambda, because we're working within AWS, and Lambda is the service on AWS that lets us run functions without any kind of without thinking about servers, as the sort of strapline goes. Yeah. I'm going to show you how to create Lambda functions, test and do the testing and logging of Lambda functions, how, if you need to, you can upload Node modules for your Lambda functions, and also they've got a couple of kind of configuration things, particularly the timeout that you need to be aware of. And then we cover triggers. So the whole point of Lambda functions is to be able to connect sort of different events together, in the cloud in this kind of event processing kind of architecture. And then I'll just very briefly show you how you can, access DynamoDB from Lambda as a kind of example of how you can access, other Amazon services from within Lambda functions. Okay, so what's this all about? Yeah, so, as I've sort of mentioned in various previous lectures, the old school approach was to, have this sort of cold room somewhere on the company premises with massive air conditioning fans and all this kind of stuff. And then they'd have a bunch of fairly expensive servers running on there. And then these servers will be used to deliver the company's website and web services. Yeah. So they have, instances of Apache or Node or whatever it is running on these servers, and then they have to hire people to look after these servers. And then on these servers they run, the server software like Apache and so on and so forth. Yeah. The server software waits for connection, sits there on the server in this sort of very loud, cold room, handles the request, then kind of keeps on waiting. Yeah, and then the company themselves have to scale up and down this equipment that they're running on their premises, and they also have to handle the backup to a remote physical location. So with the cloud, sort of initially, kind of people who are using the cloud kind of copied this model, right? Instead of having their own servers, then they just rented servers, from people like Amazon, just for, in a server farm, right? So the model was the same. They were still sort of having a sort of physical or virtual machine, except they were paying money to use a physical or virtual machine in the cloud rather than using a physical virtual machine on their actual premises. Yeah, so it saved them some money, but it didn't entirely save them kind of convenience, because you're still running server software on these servers that you're renting from Amazon or other people. So yeah, I've sort of talked the talk on the kind of servers of company premises. No one's really very tempted to do that anymore. Cloud servers have they're not that cheap. I mean, the one thing that costs a lot of money on Amazon Web Services, at least within the scope of this coursework, is running servers. Yeah, so the moment you start up a virtual machine, you start paying for that virtual machine to run. Yeah, so if you're using this kind of sort of traditional approach, but in the cloud, where you sort of install Apache or Node or whatever in your virtual machine, and then that virtual machine sort of sits there grinding away, you're paying for that virtual machine whether it does anything or not, usually. Yeah. So that virtual machine still has to sort of sit there and wait for connections, and then if you've got like your customers expand or something, then you need to expand the number of virtual machines that you're running in the cloud, or contract them if you've got less customers. Yeah, and you can set policies. That Amazon has this kind of elastic compute sort of stuff, which you can presumably set. I've never played with it, but you can presumably set it so that your number of servers expands and contracts. They kind of clone the servers for you, but then you still got a sort of bunch of hassles associated with it. And you're still paying for the server all the time that they're up and actively running, yeah? So it's not such a great solution from that point of view, yeah? So this sort of led to the development of serverless computing, and I really like serverless computing. It's sort of, in my opinion, way better than running sort of servers on virtual machines or real machines, yeah? So here we're running functions in the cloud instead of a server, right? So what a server does, effectively, we created, for running like a RESTful web service or something, you have different paths, and then you have an incoming request, and then there's a bit of code that handles that request. You've got a process where the path is mapped onto a particular function in your code, and then that code executes, and then returns the result back to the client. Yeah. So all of that, and so what serverless computing is it kind of breaks down the sort of two parts of the problem. Yeah, when we're talking about delivering a web service, for example. Yeah, you've got the kind of mapping onto paths, and then the calling of a specific function. Well, that in the cloud, if you're doing a serverless approach, is carried out by a service called API Gateway, which is the sort of the place where the sort of outside world, so to speak, communicates with stuff inside the cloud. And then API Gateway does the job of mapping a particular path onto a particular function. And then the other aspect of this is the Lambda functions in AWS, and these are functions that are executed in the cloud in response to different events. And one of those events could be an incoming incoming HTTP requests from a client. Another event could be sort of DynamoDB change or something like that. So we can generate these, call these functions in response to lots of different events in the cloud, and so and that provides a much more sort of elegant architecture without having to get these servers running on virtual machines. Yeah. So there's still servers in the loop, right? But we don't have to care about them anymore. That's why it's called serverless computing, yeah? It's called running functions, running code without thinking about servers, yeah? So the functions, as I said, can be triggered by events generated by HTTP requests, but they can also be triggered by other things like a database update or, something being uploaded to an S3 bucket and so on and so forth, yeah? So one quite helpful way, I think, of thinking about this is as a JavaScript application running in the cloud, right? Assuming you're writing this in JavaScript. I mean, serverless functions can be written in lots of different types, lots of different programming languages. But if it was JavaScript, when we're running JavaScript in the browser, we don't just sort of have a single sort of, loop that just keeps executing, right? JavaScript's an event-driven architecture, so you can so if you're running stuff in the browser, something happens, like the user does something and it calls a blob of code, or some timeout expires and then call a blob of code and so on and so forth. And the same idea exists in the cloud, that when something happens, it calls a blob of code that handles that. That might trigger another blob of code, or it might just, return something to the user and so on, yeah? So yeah, I think that kind of explains that. So one of the advantages is scalability, right? Since we're not managing servers, we don't have to worry about how many servers are running, and so these kind of weird spikes in demand you get sometimes, we don't have to care about. You might have to configure a few policies and concurrency and stuff like that, but if that's really just a few parameter settings for your serverless functions, yeah? In theory, the kind of cloud provider will scale capacity to match demand. So if you have a sudden spike in demand, it can just call this blob of code in your Lambda function like thousands of times instead of just hundreds of times or no times at all. Yeah, it can very rapidly expand and contract in response to what customers are doing. And it can expand to a very high level of performance, right? So, this is an example from a talk I went to a few years ago. So the financial engines, they're handling, 200 to 300 requests per month, 60,000 per minute, 0 server downtime, right? That's pretty awesome performance, right? And it can be achieved, without enormous complexity, right? Because a lot of the complexity of scaling these things up is handled by Amazon, if you're using Amazon. Another really nice aspect of this is pay-as-you-go computing, right? So you're only paying, so there's a small amount you've got to pay, just to store that function in the cloud. I said everything in the cloud has a cost, but most of the cost associated with functions is the runtime. So if you have a lot of functions running, or if your function's running, a lot of times in response to customer requests, then you pay for that. But if no customers are using your function, then you're paying just the very basic storage for that, which is very cheap, yeah? So you don't have to, so you're only paying for code that's actually running with a serverless approach. And so that can make it much more, cheap for companies to run, because they can expand from a very small number of customers to a very large number of customers very easily. And then because they've got more customers, then they should be able to pay for the greater amount of server capacity, greater amount of serverless functions that are running, yeah? And developers don't have to waste their time on server management either. So that's sort of also cutting down the costs, yeah? So I said I really like the serverless architecture approach. So I think you can get a nice clean architecture with this kind of event-driven JavaScript running in the cloud. It's easy to hook Lambda functions up to events such as database updates, and I'll show you how to do that now in this lecture. And then, these things can interact. There's lots and lots of AWS services. Again, Lambda, the serverless exists on various different cloud providers, but obviously here I'm focusing on Amazon because that's what we're using for this course. And so Amazon has lots of AI services, like we're going to be using Comprehend's natural language service and the SageMaker machine learning service. So we can just hook up our Lambda functions to these different services in order to really kind of power, add lots of, good stuff to our, online application, yeah? So there's pretty much every big cloud provider now has a serverless runtime, yeah? So here I'm going to be talking about AWS Lambda, but there's also Google Cloud Functions. There's some kind of open one called OpenWhisk by Apache, which I think is implemented maybe by the IBM one, or anyway, it doesn't really matter. So here we get, so obviously if you're end up working in a different cloud provider, you can still work with serverless, and I'm going to show you how the Amazon serverless works. Probably the other ones work in a similar way, yeah, but I haven't tried them. Okay, so this is AWS Lambda. We're going to focus on here because we're using Amazon Web Services. It's been around for a while, since 2014. Apparently, according to some talk, it's like the first abstract serverless computing product. And again, this is going back couple of years before COVID when I went to this kind of seminar and this kind of stuff run by Amazon. But they have a lot of customers running serverless, and these customers are doing some pretty impressive things with the serverless architectures. Yeah, so this is like maybe 5 years ago, but now the amount that people will be using this will have increased massively. And what you'll notice as well, if you do go along to the Amazon events, that the serverless ones are always packed. Yeah, because everyone's really kind of into this kind of serverless architecture at the moment. Yeah. So, these are some examples, right? Thomson Reuters are using, processing 4,000 requests per second. We've got Milbam ingest, 17 plus petabytes of data per season. That's an enormous amount, right? That's like baseball rate. 500 billion validation of stock trades daily. These are big scale things doing a lot, and they're running this stuff on serverless. Yeah, so it's a high quality product Amazon's delivering with this. Yeah. So I hope I've sold you on the idea, and I mean I'm totally sold on the idea. If I was building a cloud application, I wouldn't touch virtual machines or EC2 instances or any of that. I would just use serverless because there's so many advantages to it. So there's a couple of ways in which you can build these things. Yeah. So you've got the AWS Management Console, which I introduced in the previous lecture. Or the AWS command line interface, which I haven't played with, so I can't really comment on what you can do with it. I imagine you can do the same sort of things as with the AWS Management Console, just by typing commands like it's like a shell environment, right, that lets you configure your cloud. Yeah. So the AWS Management Console, and that's what I'm going to cover in this lecture. We can kind of there's a kind of graphical environment where you can edit code, run code, test code entirely in the cloud, but using the graphical tools provided by Amazon. Yeah. The other way we could build kind of architectures, serverless architectures in the cloud, is using either kind of one of Amazon's frameworks, so the serverless application model, that's Amazon's own framework for deploying applications in the cloud. And they've also got a JavaScript kit that lets you build cloud architectures using JavaScript code. Yeah. And then there's a third-party Node module called Serverless that lets you build and deploy serverless architectures. And the advantage of Serverless is it's a third-party, so it'll also run on other kind of cloud services like I think Azure and probably Google. Yeah. So if you're in a professional company, you would certainly use an infrastructure as code framework, because that makes it very easy to kind of check your code prior to deployment, check your cloud infrastructure prior to deployment. You can do all this kind of static sort of checks on the thing, and then it also makes local logging and stuff very easy. But most importantly, you can kind of version your cloud infrastructure and kind of back it up. Yeah. So if, for example, you lose your account, as what might happen to one or two of you this year if you run out of credit, then you can easily, if you're using an infrastructure as code framework, just redeploy the same architecture into a different account. Yeah, so it makes it very easy to switch between accounts, version it, see changes and all the rest of it. Yeah, you can treat your infrastructure as code, and that's the whole point of the kind of the little catchphrase. Yeah. So for any professional company, that's what you would use. Yeah. In the case of learning it, though, I think it's probably too big a step to kind of ask you to do infrastructure as code when you've got no idea how the infrastructure works and how to string things together. Yeah. So for this course, I'm going to focus on teaching it through the AWS Management Console. But if you're feeling keen, you can watch the lecture on infrastructure as code, and then you can kind of do everything in that approach. The nicest approach to do cloud infrastructure, in my opinion, is to use one of these frameworks, but write everything in TypeScript. Then you can kind of transpile it to JavaScript, and then automatically kind of deploy it, or automatically or manually kind of deploy it to the cloud, and then you can monitor all the changes and logs locally. Yeah, that's a really nice way of building cloud architectures. But I'm not going to do that, because it's better to you can do it, but I'm going to focus on teaching it so you can understand all the services, and then in your next stage of learning this stuff, you can then move on to actually use one of these infrastructure as code frameworks. Yeah, that's certainly the way I've learned this, and I think it's the best way to teach it. Yeah. Okay, so what we're focusing on here is the AWS Management Console, and it provides a pretty nice environment for writing your Lambda code and testing it, deploying it, and connecting it up to things like database events. Okay, so yeah, let's sort of cover that point. Yeah, so we're going to cover infrastructure. There is a lecture on infrastructure as code. Welcome to use that approach, but I'm going to focus on the AWS Management Console here. Yeah. Right, so let's crack on. So let's start with. So I'm going to show you some basic hello world sort of stuff in order to get you going with this. Yeah. So Lambda Function. So as everything in the cloud typically needs permission of some kind to interact with something else. Yeah. So Lambda functions, if they just want to run by themselves, I've never tried this, but you can just create a very simple role that will just let you execute some basic code running in the cloud by itself, yeah? But most of the time what you want to do with Lambda functions is interact with databases, interact with API gateway, interact with, natural language services and so on and so forth, yeah? So you need to give your Lambda function permission to interact with the other web services, yeah? Now, permissions are granted on a specific entity. I'm just calling that E1 for illustrative purposes, and that gives the entity permission to carry out a specific action on another entity. Yeah. So you can think of it like roles in society. Yeah. So if I'm a policeman or woman, then I have permission. Then I'm a particular entity, the policeman or woman, and I have and the permissions, because I'm a policeman or woman, I'm allowed to say arrest people, and these other people could be other policemen and women, or it could be just ordinary citizens, kind of thing. Yeah. So being a police person or soldier or whatever, you're an entity, you're in a particular role. You're the entity, and then that being in that role gives you permission to carry out a particular action on something else. Yeah. Okay. Now within AWS, they have a Iam Service. I can't remember what that stands for, and that is sort of graphical, or there's other ways of configuring it. That's a way in which you can create different roles that give your Lambda function permission to carry out different actions. Yeah. So here with Lambda, we'll come to this later, you have to specify the role that the Lambda function has. So obviously the entity here is Lambda, but the role gives it permission to carry out specific actions on other web services, yeah? So if it wants to access DynamoDB, it needs to have permission to do that, yeah? So what we would do if we were a commercial developer is we go into the IAM dashboard, or, there's probably a way of doing it on the console or some other way. We go into the IAM dashboard. I think with the infrastructure as code frameworks also let you create roles. We create a specific role saying that we're going to grant Lambda functions permission to, for example, access DynamoDB with certain operations, and then we'd use that role, give it to the Lambda function, and the Lambda function could do those operations. Yeah, so that would be the sort of standard kind of way we do it in an ordinary AWS account. Yeah, to cover that. But to make things easier for the students, I guess, AWS Academy has done things slightly differently. So what it's done is it's created a standard lab role, which you can just use for all of your Lambda functions. This lab role has sufficient permissions to be able to do what you need to do within the cloud space. It's a bit like you'll often see cloud tutorials where they kind of use IAM to create an administrative role, and then you just give that to everything to make life easier, yeah? So the lab role is a bit like that. Obviously in a real system, we wouldn't want to just give our Lambda function permission to do everything we liked, because we might make mistakes, or might get hacked or something. So we need to make sure that the Lambda function has the minimum, no more than the minimum set of permissions it needs to run, yeah? But in your case, you don't have to worry about all this. You can just use the lab role, yeah? So just remember the lab role, because otherwise your functions will not work, yeah? Okay, so when we're creating the Lambda function, I'll come to this with a demo. We select use an existing role, and then we choose the lab role, and ignore the RoboMaker students. Have no idea what that does, yeah? The lab role is the one you want to use, yeah? Okay, so that's the permissions we need to give to our function. And then to create it, it's pretty easy, right? We go to the Lambda console, give it a name, select the runtime, give it lab role, click on create function, and then we can edit the code, and off we go, kind of thing, yeah? So this is like in the create function page, we give it a name. So the runtime, you can use Node, obviously, but you could also write your functions if we were not doing this particular piece of coursework. We could use, I think you use Scala, you can use all kinds of different programming of languages and environments within Lambda functions, yeah? For this coursework, you must write your Lambda functions in JavaScript, yeah? So you can write them in TypeScript and convert them to JavaScript, but ultimately what appears in your Lambda functions, what you submit for your final submission, must be written in JavaScript, yeah? And I will not accept any submissions in Python or any other programming language, yeah? So because, JavaScript does the job, and then, that's what, and it reduces the amount of copying of random machine learning websites, yeah? So that's another reason, yeah? So it must be written in JavaScript, yeah? Then with permissions, which are covered, yeah, then create function, and then we end up here with our new function, and then we can start to actually run code in the cloud, yeah. So to edit the code in the cloud, where I'm going to be teaching it is you can just sort of edit it in the browser. Sometimes I'll edit the code locally and copy it across, because, the online development environment's all right, but, it's not brilliant. So we edit and test the code in the browser. It's got that full development environment there. And then to save changes, it doesn't have a save button, it has a deploy button, but it does the same thing. Yeah, so if you try and run it without deploying it, it'll be running the old version. Yeah, so make sure you click on deploy to basically make it a live function with all your changes in it. Yeah. Now this is a crucial point. So unfortunately, there's no safety buffer in the AWS Academy account. I mentioned this already, and unfortunately, unfortunately, the credit is a little bit inaccurate, and they don't have any ways of managing your credit in educate accounts. Yeah, so you must, when you're creating and editing your code in the cloud, you must make a copy of that and keep it locally. Yeah, because the code is the most crucial part of your cloud application, right? And if you lose that code, because you run out of credit, then it's gone forever. Yeah, once your account runs out of credit on AWS Academy, it's gone. Yeah, and you've lost everything in there. Yeah, but if you've copied the code and kept a local copy, then it won't take you very long to reconstruct your cloud application. Probably less than an hour. Yeah, because you'll know how to configure everything by then. You'll have written all the code. You know the code runs, and so you can reconstruct your project quite easily if you run out of credit, as long as you've got a copy of your code. Yeah, but if you haven't got a copy of your code, you're in real trouble. Yeah, so please always back up your code from the cloud, because like I said, if you run out of credit by accident, or whatever, then it's gone forever. Yeah, so just take that as a severe warning. Yeah, and be careful with your code and always back it up. Yeah. Okay, so that's the sort of development environment. So let's actually make a start on this. Yeah, let's actually do some coding. Let's organize myself here. Righty-ho. So here's the management console. Okay, so this is what you get once you've clicked on the AWS button. Okay, so IAM, as I said, that's how we do the identity and access management. I think that's what that stands for. And then we can open up Lambda. I'm also going to open up DynamoDB and CloudWatch for the moment, but let's just focus on Lambda. Yeah. So let's just show you how to create a function, right? So you have a list of all the functions you created already. Yeah. And then we can just create a new one. So we can call this, demo1, for example, not the best name. Like I said, there's lots of different environments you can run, but here in this coursework, we're going to be focusing on Node.js, so stick to that, please. Architecture, you don't really care about. And then we can choose, and then we need to select the role. So remember, we need to use the existing role, which is the lab role here, yeah? Advanced settings, I think we can ignore for the moment. So here's our, very simple. And now I've created my Lambda function demo1, and we're going to go into some of these things as part of this lecture. Yeah, it's not like a comprehensive, definitive lecture on this stuff, but enough to kind of get started and do this coursework. Yeah, right. So that's how to create a Lambda function. In a couple of clicks, like less than 10 seconds, probably. Yeah. Okay. Anyhow, so currently Lambda supports Node.js 14, so it's got all the modern JavaScript features. I think you do classes if you really wanted to, modules, all the rest of it. So use modern JavaScript in your serverless code. Please don't use var or any of this ancient stuff. Yeah, please don't use prototypes, they're just hideous. Just stick to the modern JavaScript features and write nice clean code. Yep. So in theory, you could write your serverless functions in TypeScript and transpile them, and then copy the transpiled JavaScript into the AWS serverless. I personally wouldn't bother, because that's not a very elegant workflow, to say the least. The best workflow, if you want to use TypeScript, is use a framework like Serverless. Then you write your code in TypeScript, and then it gets transpiled automatically to JavaScript, and then you deploy that JavaScript, using the serverless command to put it into the cloud. Yeah. So I wouldn't worry about it. You need to use TypeScript for local code that uploads data to the cloud, the data from web services. But beyond that, just regard that as an introduction to TypeScript. I'm not expecting you to use that for this project in other ways, though of course you can if you want to. If you want to write the TypeScript for the front-end code, that would be quite sensible, because TypeScript's a better programming language than JavaScript. Yeah. Okay, so testing and logging. So you can't write code unless you can see what that code does, obviously. Yeah. Yes, it's a couple of things I need to explain before we get into the actual sort of testing and logging. So when the Lambda functions are called in the cloud, they're typically called with 2 or 3 arguments. Yeah. So if we go back to, let's just get out of here. Where are we at? Yeah, here, demo1, right? So if you look at this, the default kind of hello world thing it creates has this event object, yeah? But we can also have another couple of event arguments, sorry. And we can have another couple of arguments called context, and we can another one that's like a callback function, yeah? So let's just get back to here, okay? So the event object's the one you care about the most, and that's why they leave that in by default. because whenever an event triggers the Lambda function in the cloud, that event object contains details about the event that triggered it. Yeah. So for this coursework, we're going to be doing sentiment analysis of data uploaded to DynamoDB. And so what we can do is set up a trigger so that DynamoDB will call the Lambda, when changes are made to DynamoDB, the Lambda function will be called with an event object that contains details about those changes. And I'm going to cover that a little bit later in this lecture. Yeah. Context I've never had occasion to use, but it's kind of got some sort of details about, you know, the context of the invocation of the Lambda function, the execution environment, and so on and so forth. Yeah. There may also be a callback function. So I'm focusing in all my code now, I just use async functions. But if you wanted to use a function that was not async, then you could have a callback function that be called when the function was complete, kind of thing. Yeah. But I use async stuff anyway, which returns a promise, right? As you know. Yeah. Okay, so for example, when there's a DynamoDB event, then that will have a sort of, we'll call the function, and then the event object will look like this when a DynamoDB function triggers a Lambda function. Yeah, DynamoDB change, sorry, triggers a Lambda function, and I'll use this as a concrete example a little bit later, so don't worry about the details right now. Yeah, and this is a context example. It's like the function name, memory, you know, other bits, log streams, this kind of stuff. Yeah. So when we write our Lambda functions, the easiest way to test them is using the online development environment. Yeah, so what we need to do is create a test event, and when we click on test, that test event, the object in the test event, is copied into the event object that's passed as an argument to the function. I'll show you how this works. It might sound a little complicated, but it's not really. And then we can call that function with the test event and see the results of the test in the development environment. So to create a test event, we go to the sort of test tab, you might say, or test link, and then we can create new events and give them names and stuff, and then select the test we want to apply. And then when we click on test, this test object here is copied into the event argument that's passed into the Lambda function. Yeah. So, and I'll demo that so you understand what I mean by that. Yeah. So that's the testing, right? And when we're running functions, we need to be able to see the results of what happens when they run. Yeah. So logging is crucial to any kind of code development because most code fails and then we have to fix it and so on and so forth. Yeah. So logging in AWS Lambda is done in three ways. And obviously this logging applies not only to AWS Lambda, but any of the cloud services that have logging. So when we come to WebSockets, for example, we can enable logging for API Gateway, and then we can see what's happening with API Gateway and pick up errors, which often occur. Yeah. Okay, so there's three kind of four methods, I guess, for logging with AWS Lambda functions. So as I said, the easiest one is if we can get an appropriate test event, then we can execute it locally in the Lambda development environment, and then we can see the results just straight in that environment. Yeah, that's the easy way to do it. CloudWatch is the sort of big iron kind of complicated logging system that for all AWS services. Yeah, it's harder to use. You have to use it sometimes. You can't avoid it, but you know it's a little tricky and a little clunky. Yeah. Quite a neat solution I found for this is called the CW CloudWatch tailing tool. So tailing is when you follow a log stream, and whenever it changes, you output the latest changes. Yeah. So I'll show you how to set up and use that. That enables you to view the logs of your Lambda functions just locally on your machine. So you can kind of you can sort of trigger the Lambda function by uploading some data, for example, and then you can see the results of the Lambda function's execution just in your local machine, which is quite handy, I have to say. Yeah. And then if you're move on to the kind of more infrastructure as code frameworks like Serverless or AWS SAM, they obviously include logging as well. So when you deploy your function, you can then see the logs of the functions as they're executing in the cloud, yeah, on your local machine. So online development environment, for putting together a piece of code that does some data processing, for example, this is probably the easiest way to view the logs. We create a test event, execute the function, and then view the logs, yeah. The crucial limitation of this is it doesn't work when the Lambda function is executed in response to a trigger. So if the Lambda function is called by API Gateway, for example, you won't see the logs in the online development environment. Yeah, the logs will only appear in CloudWatch or CW, which basically follows CloudWatch. Yeah, or the infrastructure as code framework. Yeah, so online development environment's good, but limited. Yeah, because triggers don't when a function is triggered, the logs don't appear. So these are in the online development environment. I'll do a demo of this. We can see, whenever we create a test event and click on test, then we'll see the results of the test appearing there. Yeah, so that's a very handy way of, getting your function working, getting the event processing working, and all that kind of stuff. Yeah. Then we've got CloudWatch. So it's CloudWatch is a separate service. Okay, it's powerful, not particularly easy to use, said, and it's a little bit laggy. So, you know, particularly I was testing the API gateway yesterday, and then it took maybe 1 or 2 minutes before the logs appeared from the invocation of the particular sort of from the API gateway stuff I was using. Yeah, and you know, so you sometimes have to wait a little bit, and it's got these kind of weird sort of log groups, which you know you have to fish through. It's not the easiest thing to use at all, but maybe that's because I'm not a very good user of it. Yeah. So you see that, you click on the sort of logs, I think you click on logs, and they give you all the log groups that you've got active at the moment. And then you click on the log group you want to see, and then you have all this kind of, these sort of log groups kind of broken down into they're sort of grouped into time periods, I guess. So you select the latest one usually, and then you can actually see the log, you know, appearing, yeah? So as I said, CloudWatch is all right, but there's easier ways to use it, and CW is one of these, yeah? This allows you to see CloudWatch logs on your local machine, but to make this work, your AWS credential file needs to be in the right place, because what CW does is it uses the credentials file to authenticate itself with the cloud, and then it pulls the logs from the cloud, yeah? And the crucial thing you need to add to your AWS credentials file is the region, yeah? You need to say region equals US East 1, because that's the one you're using for AWS Educate, and then CW will be able to pull the logs from your account, yeah? So there's a web page there, explain how to use it. I'm not going to bother showing you how to set it up, but I will show you what it does when we actually use it, yeah? So it's got commands like CWLS groups, which shows you all the log groups, and then you can tail a particular one. As I said, tail means it grabs this sort of end of the log file, and then whenever that log file changes, it will output the latest changes, yeah? So tailing's -F means it'll follow it and just sit there on your machine waiting for the log to change, and whenever it changes, it'll output the changes, yeah? Okay, so let's actually do a demo of this. Okay, so this demo, may go wrong, but we'll do our best, yeah? Right, so what are we covering here? Yep. Okay, so testing. All right, yep. So let's start with testing. Okay, so let's go to our test page, yeah? Because in order to invoke the function from within the online development environment, we need to kind of a test object, yeah? So at the moment, we're just using a sort of really not particularly exciting test object, but let's say we've got something like name, we can just make this up, yeah? Jane, for example, and then, I don't know, age, let's just put 22 or something, yeah? And that'll probably do, yeah, that's not going to go wild, yeah? So we've got a test object that doesn't correspond to very much, frankly. And then we will, let me save this. Oh, save changes, that's it, yeah. Okay, oh yeah, I need to give an event name, so let's say test person or something, yeah? Test person. Okay, so we'll save the changes, okay? And now let's just go back to our code. So this is our online development environment, and maybe it's a bit small in this video, so let me just make the code editor, wait a minute. I'm just trying to get the size a bit better, if I can do that without killing myself, yeah. Usually I can make this thing bigger. Just one sec, yeah. User settings, maybe. I shouldn't be doing this now. Never mind, we'll just probably have to live with it. Code editor, there we go, yep. Okay. Font size, yeah. I'll just make it a bit bigger so it's easy for you to see, yep. Okay, so that's all right. Okay, let's just go a tiny bit larger. Okay. Yeah, hopefully that's clear now, yep. Okay. Okay. Righty-ho. So we've got our test object, all right, and then we've got our Lambda function. So what I'm going to do, so when we call test, this event will contain everything inside the test object, yeah? So just to sort of show you that working in all the logging and so on and so forth, let me just my keyboard. I'm going to set up here. Okay, console log. Right, so usually it's sort of not always obvious whether you have to stringify it or not, but if it's not obvious, then generally I stringify stuff just to make sure it's not trying to log a sort of binary thing, which sometimes falls over and dies. So what I'm doing here is very simple, right? I'm just logging this particular event just to show you that when I call test, we see the contents of the event contains the contents of the test of what we've created as our test, yeah? So to save it, we deploy, yeah? And now we can call test. And as you can see, I'm logging out in JSON format because it's stringified the test object that I created here, right? So that's copied into our test object here, Let's get rid of preferences. That's been copied into here, and then we're just logging that out in JSON format. Yeah. So once we've got an appropriate test object, you can see it's pretty easy to kind of call the function with an appropriate test object, and then we can then write the code that processes that particular event. Yeah. So that's one form of logging. This is the sort of the logging in the online development environment. Yeah. Second kind of logging is we can kind of open up. I'll open it up directly. You can open up from Lambda, but I'm just going to open up directly here. So if we go to CloudWatch, which we just search for the service there, then we've got log groups, and here we have a list of all the different sort of services that I've created as part of my kind of testing and all the rest of it stuff. Yeah. So here we've got demo 1. This is our Lambda function we're looking at here. And then here we've only got one log stream because we've only just run it. Yeah. So we can click on that, and then if we go into here, then we can see, and it's actually, here's what we just logged. Yeah. So you can see it's not the easiest thing to use compared to, here. But as I said, it works in ways under when the Lambda function is called by triggers, which this doesn't. Yeah. Now the third way I'm going to show you how to do logs is with this CW tailing tool. And I think if we just remember the CWLS groups, I think it is. So I've installed it. Just follow the instructions to install it. It's pretty easy to install. So once it's installed, then you need to make sure that I've copied my credentials file here, and I've added region equals US East 1. If you don't have that, CW complains it can't find the region. So you need to make sure you add the region to your credentials file. And then if we do ls groups, I think that should work. Then it's listing all these kind of groups. You can see demo 1 is here. Now I just need to remember the command, which is CW tail and then -f. Yeah. Okay, so now if I do CW tail, the particular group I wanted to follow, which is /AWS/lambda/demo1. Yeah. Okay. So we're tailing that. Okay, so when you take, didn't do -f, so there'll be no changes, right? If I do -f, then it's going to kind of sit there and follow it. And so whenever I call that Lambda function and there's new changes to the logs, we'll see it appear there with a bit of luck, yeah? So if we go back to our demo 1 test, let's call the name to, John or something, yeah? So we'll change our test object, yeah? We'll save our changes. We'll call it again, okay? So we call test. Then we go back to CW. There's always a little bit laggy. Probably should have tested this myself before. May have to come back to it. And it also caches, right? So the oh yeah, there we go. Yep, it's worked actually. Yeah, there we go. Yep. So there we go. So it's a slight delay, but not terrible. So here we got. You can see now it's kind of John, and it's logged out John. And then if I called it again, it would kind of keep, I'd be able to see all the logs appearing as they came. Yeah, it's probably slight, and you can see with CloudWatch to kind of view this kind of change, because we'd have to go back in here, and then now we can see the John thing appearing there. So it's not terrible in CloudWatch, but it is more complicated than just following it like on our local machine using CW. Yeah. Okay. So that I think is the testing on the development of CloudWatch logs. Yeah, I covered that. Okay. Right, so if you look at the online development environment here, there's no facility here for, there's no sort of command line thing that we could use to install third-party Node modules, yeah? So the Node module that's always included in this development environment is AWS SDK, obviously, really. So you can always kind of use the AWS SDK within JavaScript to do different things like access the database and all that kind of stuff, yeah? But suppose you wanted to use a third-party Node modules like Luxon or Moment, or, maybe a CSV, processor or whatever it is, yeah? There's no sort of facility within the online development environment to use NPM to load these different Node modules, yeah? So the way you have to do that is by uploading the Node module into the cloud, and then you can actually run the sort of Node module, yeah? So as I say, AWS SDK is included, so we don't need to mess around with installing anything if we just want to work with the AWS services, yeah? But to use a third-party module, we have to upload the code for that. You don't, it's very rare that you'd need that for coursework 2, but if you're doing like polynomial regression or something, then maybe you might need something like that, yeah? So doing it's pretty easy. You create a zip file containing the node modules folder that has the libraries, and then you can also put your own code into that as well. Then you upload from zip file, and I'll show you how to do this. And then, but when you do this, it will completely overwrite everything in your Lambda function. Yeah. So if you've got some nice code that you've written, and you say, "Oh, I'd like to add a node module to that," and you try and upload the node module, it will just wipe all your code. Yeah. So just make sure that you're totally willing for your entire Lambda function to be wiped when you do this, because it will replace everything that's in there. Yeah. Obviously, if you've got the copies of that, that's fine. You can just paste it back in. Yeah. Or you can just put it into your local code that you upload with a zip file. Yeah. But just bear in mind that that will happen. Yeah. Okay, so let's just quickly show you how to do that, because it's something you might need to do. Yeah. So here I've got like what I've called test upload, right? And I've got an index file here, which well, it doesn't matter about right now, but it kind of just uses this third-party library Luxon, right? And it uses Luxon to kind of format a particular date, time, and output it to a string. Yes, I'm just showing you how to use a third-party library. This function itself is not remotely interesting. Yeah. And then inside node modules, I've installed using npm. I've installed Luxon. Yeah. So for my test upload, I'm just going to get these two things: the code I want to upload and node modules, and I create a zip file here. Yeah. So you need to create a zip file so that when you go into the zip file, this stuff's all at the root. Yeah, you don't want to create a separate folder and then, because that's going to create problems. Yeah, so like that, just zip it up, and then you've got test upload here. Okay, and then here we can do upload from zip file. Okay, I don't know if I can drag it across, and it gives you the warning about overwriting all the existing code. I will try and drag and drop, but it might not work. Yeah, nope. Okay. Okay, so what did I do there? Okay, right. So click on upload, and then here's my test upload anyway. Yeah. Okay, so open that, and then we click on save, and then the code's been updated, making changes. Okay, there you go. Yeah. All right. So now you can see now it's uploaded index.js. It's completely overwritten all the existing code, and now I have my Luxon module inside here. And then if I run this thing, then I should see this here. And so this here is what's being output by my datetime function. It's done the appropriate formatting using Luxon, because it's using now the node modules thing in here. Yeah. So this just shows you that it's working. Yeah. Okay. So I think it's pretty clear. Okay. So something to be aware of with your Lambda functions is that they have a timeout. Yeah. So AWS, the execution environment for Lambda, will only execute that function for a specific time, because obviously functions get stuck or get locked up or whatever. So as a way of sort of avoiding functions just running forever and costing the customer a lot of money, it will shut the customer. So if the function tries to run and it fails for some reason, then it will try to execute it again. I think it tries like a couple of times, and then it will just sort of shut down and give up, kind of thing. Yeah. So it has a timeout, and the default timeout is 3 seconds. Yeah. Now, for a lot of stuff, like handling an API, HTTP request from the API gateway or something, then that's completely fine. 3 seconds is plenty, right? Which is why they set it as the default. But if you're doing a lot of processing of DynamoDB events, for example, suppose you upload 100 items to DynamoDB table, and then you're processing them with your Lambda function, that's going to take significantly longer than 3 seconds to work through those different things. So usually you need to think about what your Lambda function is doing and potentially extend the timeout so it has more time to work. Yeah, as a general point, obviously, the longer the function runs, the more money it costs. But if the function fails because of the timeout, then it's going to be re-triggered multiple times, and that's also going to cost money. So and if your function doesn't run at all, it's completely useless. Yeah. So you need to give your function enough time to run, and obviously if it stops sooner, then that's fine. But if it's terminated by AWS before it stops, then that's not fine. Yeah. So you need to tweak the timeout so that your functions work nicely. Yeah. It's pretty easy to change. You click on configuration, general configuration, edit, and then just change the time. Yeah, so it's got these kind of tab things at the bottom of the execution environment, and then you can click on edit, and then you can change that timeout. Yeah, I usually stick it on about a minute for stuff like database processing, and then that usually works just fine. Yeah. Okay, so that's just something to bear in mind, and you can also, I think, change the number of retry attempts, and if you want to, although why you would want to is a bit of a question. It's better to change. Usually things fail because the time's out, rather than trying the function multiple times is a bit pointless because it's probably just broken code. Yeah. Right, so this is, one of the sort of real nice, elegant things about Lambda functions, that we can call them in response to cloud events. Yeah, so when I upload something to S3, for example, we can trigger a Lambda function that's called to kind of process whatever we've uploaded, for example. Or if a DynamoDB table changes, again, we can call a Lambda function automatically to handle those changes. Yeah, so we can have these nice kind of event processing chains in the cloud. Now, if you remember, go back to some of those kind of financial or kind of baseball kind of statistics kind of processing companies. That's exactly what they're doing with Lambda functions, right? When you upload some stuff to that, and they will, then they'll note the Lambda function will be triggered in response to those changes, and then they can have more or less complicated chains of processing in the cloud that handle that. Yeah. If you get real fancy about this, AWS also has step functions that lets you sort of orchestrate the functions in a certain order and control the kind of relationship between them in quite a systematic manner. And there's some way that I haven't actually figured out yet, but you can actually trigger AWS Lambda functions like every hour or something, like a cron job on Linux. So you can call them regularly to do certain tasks like downloading data and stuff like that. Yeah. So in Coursework 2, the kind of event chains might include, for example, when someone uploads text data, it does the sentiment analysis on that text data, and then it stores the sentiment analysis results, and then it will update the clients, for example. Or when you upload the numerical data, it could call the SageMaker endpoint to generate new predictions, and it could store the predictions and then push those to the clients. Yeah, so those are the kind of event processing chains that we'll be doing in Coursework 2. And as I said, lots of different triggers. We'll also be using API Gateway to kind of call Lambda functions, when a client wants to connect with WebSockets, for example. And there's tons of these things, probably far more than this list, yeah? So add a trigger is easy, right? We just click on add trigger, and then there's like here, just focusing on DynamoDB as an example. Then we can add like a kind of a specific table as our trigger. And so when that table changes, it will copy the changes into the event object and call the function with that event object. Yeah. Okay, so let's just quickly show you how to add a trigger. So I'll kind of trash my function now. Yeah, that's all right. Okay, so for the moment, I'm not going to bother returning anything from this function. We're just going to sort of run it, kind of thing. Console log event. I'm going to stringify it just in case. Stringify event. Yeah. Okay. Right. So what am I doing? Adding a trigger. Yep. So let's just go back to DynamoDB. So okay. So here's my DynamoDBs, and where's my tables gone? There's my tables. All right. So I've got a Twitter table here. Yeah. And if we look at the table items, this is the kind of stuff, right? So we've got a tweet ID and text. It's not the best design, but worry about that later. Okay, so we've got a DynamoDB table here. Okay, and so what I want to do is whenever that DynamoDB table changes, I want to call my Lambda function. Yeah. So if I add a trigger here, I select like a DynamoDB trigger, and then I choose the table I want to trigger. So this is some configuration stuff which we may or may not need to change, but for the moment you can just use the defaults. So we click on add, and now this function will be called whenever there's a change to that particular Twitter table in DynamoDB. Yeah, and all I'm doing here is just stringifying the event just so we can see what's happened. Yeah. Okay. So triggering the function is just the start, right? Obviously we don't want to just trigger it for the sake of it. We want to trigger it and then do one of two things. We might have certain things we want to do when we know that the database has changed, for example, updating the clients, or we might want to be processing what's happened in the table or in S3 in order to, make some, to process the data in an appropriate way. Yeah. So in the case of sentiment analysis, for example, whenever the Twitter data changes, we want to take that text data, convert it into a sentiment analysis, and then store that sentiment analysis in the cloud. Yeah. So in order to process the changes that have happened, we need to understand the structure of the event object and probably run some tests on our code to make sure it's extracting the data that we want it to extract. Yeah. And so this is an example of a different table, but same idea, right? Suppose we were adding this kind of price type, a new kind of crypto item into our table, yeah? So we're just storing that in the table. Then what will happen is that the AWS execution environment will create this event object here. It contains a bunch of records, okay? An array of records, an array of and each item in this array is is a change that's been made to the database, yeah? In this case, I was adding this thing to the table, right? So it's an insert event in this case. And when it's an insert event to DynamoDB, because it tells us it's DynamoDB there, as you can see here, then it gives us stuff about the creation date time, and it tells us about, because it's an insert event, it tells us that we've got a new image object here, okay, that contains the data that's been saved in the table. And just note that it's got the types in here as well. Yeah, so we've got number, string, number, and when you're processing it, you need to make sure that you do the .n to extract the right part of this object. Yeah. So to process the event, we need to be able to extract this, understand this structure, and pull out the bits of information we need. And then if we were doing Twitter processing, for example, then we'd extract the text, do the sentiment analysis on it, and then resave the whole thing to the table. Yeah. And so then within our Lambda function, we can then work through the records, these records here, right, in order to be able to extract, all the stuff inside them. Yeah. Okay, and then be able to output that. Yeah. Now to set this all up, you can do it in two ways, right? We could potentially write our code in the online development environment, change the database, see if the code works by looking in CloudWatch to see that we've done the right thing. Yeah, and that's a bit of a pain, to be frank, yeah, because we have to change the database, fix code, and then look at CloudWatch and have this sort of cycle, which is very arduous, I can tell you. Yeah, it's much easier if we copy an example event into our online development environment and use that as a test event, and then we can just work entirely within the cloud. Within the online development environment, we don't have to mess around with CloudWatch, we don't have to mess around with changing the database, yeah? So to do this, what you should do is log the event object in your Lambda function, okay? And then trigger the event by uploading new data to DynamoDB, copy the logged event object in CloudWatch. I know it's a bit of a mouthful, but I'll show you, which will make it much clearer. And then we create a new test object with logged event, and then we write the code to process the event in the online development environment, yeah? So easier to show than just to sort of, to talk through, yeah? Let me just remember that. Yeah, okay, that's important. Yeah, we'll come back to that. Yeah. Okay, so I'll show you what I mean, because I realize it's completely obscure. Yeah. Okay, so here's our event. So what we have here is we've got a Lambda function that's called in response to changes to DynamoDB. Yeah. And what we need to find out is the structure of that event object. We could look it up, but then, we really want a nice example rather than looking it up, because again, our table is going to be different from the example. So it's easier just doing it this way, I think. Yeah. So we save this, yeah, we can ignore the sort of node module stuff because we don't need that. Okay, at the moment, the test, if we click on test, it's going to call test with this stuff, which doesn't look anything like the DynamoDB event object, yeah? So the easiest way to generate this object is just to create a new tweet, yeah? So what we've got here is tweet ID and text. By the way, when you're designing a Twitter table, you should probably also include the tweet timestamp, yeah? Another heads up is that the tweet ID can be tricky when you stringify. It doesn't always work, but it didn't used to work, but they may have fixed it because it's like a large number, which the stringify in Node, whatever, 8 didn't recognize, but hopefully it's got better now, yeah? But we'll give it a nice simple number here just for the sake of it, yeah? Okay, so that's like a new tweet ID, and let's put some stuff in here, okay? Wait a minute, ding item header, so forget about that, yeah? Let's get back. Well, what I wanted to do was create a new item, yeah? So I'm just copying the structure here, yeah? Okay, and then we'll create an item, yeah? So remember this thing. So I'll give it a new ID. Come on. So give it an ID, I don't know, 1, 2, 3, 4. And then we'll say, I know, this lecture is really great. Because of course it is, yeah? So we're creating just a new item, just to sort of illustrate this thing. So we're going to create an item. When we click on create item, it's going to change the database, and then that's going to call this function, okay, with the details of the changes copied into this event object. Yeah. So we'll do that now. Yeah. So click on create item, and we should be able to see the item in there, right? There's our new item. Okay. And now to see the logging. We can't see it in here, right? Obviously, because we're not calling it in the local development environment. We'll only be able to see the logs inside here, yeah? So we go here, 1126, that's us, right? And so if we click on here, yep, we got it. Here we've got our the event object that's being created by inserting the item, right? You can see, this lecture is really great here, yep. Okay, so now we copy that, okay? And then we go back to our demo, and now we can create a new test event that has that structure inside it. Yeah, let's create a new event. Save that there, and we'll call this DynamoDB Twitter or something. Yeah, we could get more, more clever and specific, but that'll do. Yeah. Okay, so we'll save changes. I think that's correct. DynamoDB Twitter. Yep, we'll save changes. Okay, so now in our online development environment, we can then we'll then be able to process this and locally, because our test event now kind of matches that. Yeah, so we're going to call it. So we're going to call this function with DynamoDB Twitter. Now we should be able to see all the records there, for example. Yeah, and if we want to write our code, we can now actually see the structure of the event much more easily. So you can see here the event has records, and then we can work through each of the records, for example. Let's just try that. I mess this thing up. I'm not certain the stringifying is a good idea, but we'll come to that. Yeah, okay, so let's just do for let record of event dot records. I might need to pass it. Okay, so working through event.records, and then console log. Now let's just see what might we have here. We might have, so each record, let's say event name. Yeah, okay. Console log event record, sorry, dot events name. Yeah, so this is why we need to know the structure so we can extract the different bits of data. Yeah, so we deploy it and then we can test it locally. Let's put in name, let's say type. That's that. Okay, so we'll deploy that. And now we can sort of click on test, and you can see it's type insert. Yeah, so it's all working rather nicely. And then if we wanted, for example, to get out the data from this event, which we would need if, for example, so you should, when you're doing this stuff, you should check it's an insert event, because obviously if you delete stuff, it's also going to call the Lambda function, and you don't want to do stuff if it's like a delete event, the Lambda function will break. So if it's an insert event, then we can do DynamoDB new image text s, right? So let's just quickly do that. Yeah. Okay, so what was it? It was DynamoDB no db, I think it was new image, I can never remember the stuff. DynamoDB new image text s. Okay, you got to get the capitalization right. Dot text dot s, right? And that's the type. Yeah. Okay, so now we can do console log text. Let's not get fancy. Plus record DynamoDB text. Yep. Okay. So let's just figure out where I've got this wrong. Yep. I forgot my thing. Okay. So again, don't click Control S. It won't do anything. You need to deploy. So now we click on test, and it hasn't worked. Why hasn't that worked? Because I've missed something. Edited that bit out. Anyway, it works. Yeah. So here we're pulling out, the DynamoDB new image.text.s. Yeah. So it does work. I know quite what went wrong there, but never mind. Yeah. Okay. So we can kind of process the data, extract the data we need, and then do something else with it. For example, calling comprehend to do the sentiment analysis, and then saving the new data back to the a new table, for example. Yeah. Okay, just a warning here. So obviously make sure your trigger event does not do something that triggers itself. Yeah. So we might have a Lambda function that's triggered by a change to the Twitter table, which then writes back to the same Twitter table. Yeah. So obviously if a change to the Twitter table causes the Lambda function, which changes the Twitter table, which causes the Lambda function, we're going to get an infinite loop that will burn very rapidly through your credit. Yeah. So what I should have added here, if I was doing this properly, is I would do if event record dot event name equals insert. Yeah. Then I would do the processing. Otherwise I wouldn't do the processing, for example. Yeah. Because, for example, if you were deleting stuff in the Twitter table, then that would also call the function, and then it would be then there wouldn't be a new image, and so on and so forth. Yeah. So we check that it's the right kind of event, and then we should insert the stuff, because then if we deleted the event, deleted it, then it would be a different structure of the event, and we wouldn't want to do the data processing on it. Yeah. Okay. So just a little sort of just show you a sort of example really, how we can write Lambda functions that interact with other AWS services. Yeah. So and just using DynamoDB as an example here, same to comprehend, the same with SageMaker and so on and so forth. Yeah. So the code for writing Lambda functions that interact with AWS services are same as the code you write locally. And if we're interacting with DynamoDB, we can do this using a callback function, which I think I covered and used in a lecture in DynamoDB. Don't really like callback functions anymore. I much prefer async handlers, the return of promise. And I'll show you the promise-based approach here. Yeah. So this is just a little example. Suppose you want a Lambda function that scans the table, and you might need this if, for example, you wanted to push, the latest data set to the clients. Yeah. We might want to run a scan or, maybe a query or something like that. Yeah. So as I said, the AWS SDK is built into the online development environment or Lambda functions generally, so we can just use it without having to sort of install it with npm. Then for DynamoDB, we're using like a document client, right? So we create one of those. We've got the parameters, should be pretty obvious. And here I'm using the promise-based approach, and with a lot and possibly all of the AWS sort of function calls kind of thing, what we can do is append .promise at the end, and then we can use a wait, or then if you really want to kind of wait for the promise to be executed. Yeah. So this is the way I use DynamoDB and all these other services now. Yeah. And then okay, and then what we're doing is we're basically outputting that, and that's what we're seeing here. Yeah. So I mean, I can show you. I won't bother showing you actually. I think it's pretty obvious. Yeah. So we're running the same code, and then we can see the output in that on CloudWatch. Yeah. Okay. So that brings us to the end. So we've got various resources as usual. So this lecture I've been showing you how serverless computing works, why we want to use it, and how to use AWS Lambda to run serverless functions in the cloud. Yeah. So there's marks for data processing in coursework 2, all of the stuff to handle sort of WebSockets, all the stuff to do sentiment analysis, or a lot of the not all the machine learning code has been in Lambda, but some of it probably will be. And then, WebSocket functionality and other stuff. Yeah. Okay. So as I said, I really like Lambda, and I strongly encourage you to sort of, get into it and use it. Yeah. And that's it.